Alright, in the previous video I talked about the Sarus rule for finding the determinant of a 3 by 3 matrix. So if you wanna, this is a formula, but if you wanna know it, just search about it. I strongly suggest to learn the Sarus rule before this video, because in this video I'm gonna talk about finding the determinant of a 4 by 4 matrix. And of course, even about higher than 4 by 4 matrices. No, actually, I'm gonna leave it for another video because it's gonna be like it's gonna take quite a bit of time. So the key idea here is to apply the Laplace rule. Some textbook actually call it the Laplace rule, some other don't. I'm just gonna show it to you anyway. So let's suppose we have a matrix which is, I don't know, let's start with a good one this time. So 2, -1, 0, 1, 1, 0, 2, 0, 0, -3, -1, 1, -1, -1, 2, 3. So I want to find the determinant of this matrix. It's a 4 by 4 matrix. Right, how do I do that? Well, the key idea here is basically to simplify this problem down to like 3 by 3 matrices. So many 3 by 3 matrices, which are gonna give us the solution. So I'm just gonna show you what I mean by that. Let's just rewrite our matrix here. So 2, -1, 0, 1, 1, 0, 2, 0, 0, -3, -1, 1, -1, -1, 2, 3. So this is our matrix. And I'm gonna highlight where I wanna start. Wait. Okay. There we go. So we're basically gonna create another matrix that is actually made, which is actually made by using, the values that are left out. I highlighted with the green pen, to just this number here, and I'm gonna use a mat and create a matrix which is made by those other numbers. So those ones, and I'm gonna do it over and over again until I get to the final row. So let me just expand and 2, -1, 0, 1, 1, 0, 2, 0, and again 0, -3, -1, 1, -1, -1, 2, 3. So this time I'm gonna keep this one the same. I'm gonna go down here. There we go. And then again. And again, I already told you why I'm doing this, but it is gonna be crystal clear once I show you. -1, 0, 1, 1, 0, 2, 0, and 0, -3, -1, 1, -1, -1, 2, 3. Okay. So just think about this as a game for now. Just, you know what I mean. Again, gonna move down to this. And then there's gonna be the very last one. I'm gonna still rewrite my matrix 2, -1, 0, 1, 1, 0, 2, 0, 0, -3, -1, 1, -1, -1, 2, and 3. And again, I'm gonna go down to the very last one. There we go. Now, I want you to write a checkboard, what I call a checkboard. It's gonna be important. So the checkboard goes by inverting the plus and minus sign. So it's gonna be plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. So this is basically my checkboard. And since I choose to keep constant this column here, basically gonna highlight this, and this is gonna give us the sign that I'm gonna be using. So what I mean by that, well, you are really about to find out. Okay, so the determinant of our matrix, let's call this matrix A, is gonna be 1 by 1. Well, because we started with a positive sign, so we're gonna place 1 whenever we have a positive sign, and a negative 1 on the top of everything when we have a negative value, right? So 1 times the very first term that we have here, which is 0, times, well, the determinant of the matrix created by keeping the term that are left out. So the matrix of 1, 0, 0, 0, -3, 1, -1, -1, 3. So this is basically this matrix here. And then again, we have a plus sign. We have minus here. So we basically say -1 times the other number, which is 2 in this case, times the determinant for the matrix that is left out. So 2, -1, 1, 0, -3, 1, -1, -1, 3. Plus, once again, we go back to a plus sign. So 1 times, what do we have here? We have -1. So -1 times the determinant of this matrix, which is 2, -1, 1, 1, 0, 0, and -1, -1, 3, so -1, -1, 3, and again, plus, this is going to be our final matrix. So plus, and we have a negative sign here, and therefore we have -1 times 2 times the determinant of the matrix that is left out. So 2, -1, 1, 1, 0, 0, 0, -3, 1. Okay, so right now we just have, we no longer have a 4 by 4 matrix, but on the other hand, we have 1, 2, 3, and 4 3 by 3 matrices. And how can we solve this problem? Well, we can just, go ahead, solve each one of them using the Saros rule. And well, that's gonna be, pretty straightforward. Uh, so let's just quickly apply this Saros rule to each one of these metrics. Okay, so it's gonna be pretty straightforward. So we have 1, 0, 0, 0, -3, 1, -1, -1, 3. Saros rule. Okay, so we have 1, 3, 3 plus 0 times 1 times -1 plus 0 times 0 times -1 minus 1 times zoom out a little bit, 1 times -1 minus 0 times 0 times 3 minus 0 times -3 times -1. And this gives us, well, -9 plus 0 plus 0 plus 1 minus 0 minus 0, which is -8. I'm going, full speed mode and not just saying, the first diagonal plus blah, 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 because, if you want to watch that, just watch the other video, which is about the 3x3 matrices and the Saros rule. Once you do many exercises about the Saros rule, they're gonna become, fast. Even faster than me, I'm not actually that fast, especially when I'm recording. Not that I'm conscious here. No, I'm just joking. All right, so we have the other matrix. So for the other matrix, we basically have what was that? 2, -1, 1, 0, -3, 1, -1, -1, 3. Okay, Saros rule once again. So we're gonna have 2 times -3 times 3 plus -1 times 1 times -1 plus 1 times 0 times -1 minus 2 times 1 times -1 minus -1 times 0 times 3 minus 1 times -3 times -1, and all this is gonna be 2 times -9, sorry, plus -1 times -1 plus 0 minus 2 times -1 minus 0 minus -3 times -1, which is gonna be -18 plus 1 plus 0 plus 2 minus 0 minus 3, which is gonna be -18. And then we have the third matrix here, which was 2, -1, 1, 1, 0, 0, -1, -1, 3. Just like that. Saros rule once again. Come on, let's go to the 0 times 3 plus -1, 0 times -1 plus 1 times 1 times -1 minus 2 times 0 times -1 minus -1 times 1 times 3 minus 1 times 0 times, let me squeeze it, can I squeeze it? -1 times -1, yeah, I did it. Yeah, too many numbers. Okay, so this is gonna be 0 plus 0 plus 1 times -1 minus 0 minus -1 times 3 minus 0, which is gonna give us -1 minus 0 minus -3, which is basically gonna be -1 plus 3, which is gonna be 2. And then we have the very last matrix, which is this one here, which is 2, -1, 1, 1, 0, 0, 0, -3, 1. And the determinant, which is Salro's rule of this matrix, remember, first diagonal, and then we just have to do this over and over again. So 2 times 0 times 1 plus -1 times 0 times 0 plus 1 times 1 -3 minus 2 times 0 times -3 minus -1 times 1 times 1 minus the other diagonal, which is 1 times 0, times 0. Okay, so this is gonna become 0 plus 0 plus 1 times -3 minus 0 minus -1 times 1 minus 0, which is gonna be -3 minus 1 equal -3 plus 1, which is -2. So now that I have computed those matrices, using the Saros rule, we are just gonna use and plug the values back instead of having a matrix, we're just gonna plug the determinant values back. So -8 here, -18 here, 2 here, and a -2 here, and just evaluate this. So our new A is going to be 0 plus, no, I'm sorry. Well, yeah, let's just do, even though it's, well, we could just keep this because it's, times 0, but for the sake of doing all the calculation, I just did it anyway. So our new A is going to be 1 times 0, which is a little bit silly, but anyway. Times -8 plus -1 times 2 times -18 plus 1 times -1 times 2 plus -1 times 2 times -2. So A is 0. Can we read it actually from here? Plus -2 times -18 plus -1 times 2 plus -2 times -2. So A is going to be 36 plus -2 plus 4. So A is gonna be 38. So this is our final answer, 38. So the determinant of this matrix, 4x4 matrix, is 38. So you can basically see that, we basically, we're not going to deal with this 4x4 matrix. We're just gonna, use this rule, the Laplace rule, and just compute those 4 3 by 3 matrices using the Saros rule, and then find the determinant and plug it back here. So what you have to remember, just you have to choose a column which is gonna be ruled out, and you basically just go, step by step, going down the row till you get to the very last one, and you write a checkboard. You use the sign on this checkboard. It's very easy to remember, and therefore your new matrix A is going to be 1 if it's a plus, or -1 if it's a minus, times the number highlighted by, where those two row and columns that you're going to rule out meet. So in this case is 0, in this case is 2, -1 and 2, and times the determinant of the matrix that is basically created by the numbers that are gonna, be left out. So everything but the ones, the numbers that you highlighted. So 1, 0, 0, 0, -3, 1, -1, -1, 3 for this one, 2, -1, 1, 0, -3, 1, -1, -1, 3 for this other one, and so on. I mean, it's pretty straightforward. There you go here, you compute everything, and what you get is 38. Because life is 38. No, I'm joking. But, this is pretty straightforward way to compute 4x4 matrices. And this also works for higher order matrices, which I'm gonna show you in another video because we're already at 22 minutes. So I basically took me 22 minutes to compute this thing while I was talking. So it's understandable, but hopefully at your linear algebra exam is going to take you way less time, because otherwise you're in trouble. Let's say this. Okay, hope it helps. Bye again.